Welcome. Today we are addressing one of the most persistent challenges in software engineering, designing systems that evolve gracefully rather than collapsing under the weight of changing requirements. Let me be direct. Every software system you build will face changing requirements. Not most systems, every single one. This isn't pessimism, it's a fundamental nature of software development. Business needs shift, technologies evolve, user expectations grow, and markets move. Now, there's a better path than trying to predict everything upfront or making everything abstract. You design for the kind of variations you are likely to encounter. Not everywhere, just along the specific axis where change actually happens in your domain. This is about strategic flexibility, not blanket abstraction. So, the fundamental insight is this: systems vary along multiple independent dimensions. When you bake all those dimensions into one monolithic structure, every change requires understanding and modifying everything. When you separate these dimensions into composable units, changes localize to individual pieces. Now, let's see this in action with a pricing system. Imagine you're building an e commerce platform. You need to calculate the final price for an order. Here's what most developers build first: a simple order pricer class with a calculate price method. We're iterating through items here, multiplying price by quantity and accumulating a subtotal. This is basic charge calculation. Next, we need to apply any customer discounts. We check the customer's premium status and apply a 10% discount if applicable. Then we calculate taxes based on the shipping region. The tax rate depends on where we are shipping. Finally, we add shipping costs and return the total. This works and handles current requirements. The code is straightforward, but here's the critical problem. It assumes that the pricing logic is relatively stable. It treats pricing as a single unified concern. Now, requirements always evolve. 2 weeks later, you get a requirement saying we need promotional codes. You add promo code logic to this method. After 4 weeks, you get a requirement stating that premium customers get free shipping over $100. You add that conditional. 6 weeks, we are expanding to Europe. VAT works differently. You add regional tax branches. Fast forward 3 months. Let's look at what this method has become. Notice how we are now building a map to detect if certain products appear together for bundle discounts. The simple iteration from before now requires an extra data structure. Now we now have two different calculation paths depending on product combinations. We've lost the simplicity of just multiply and sum. Next comes the promotional code handling. Promo codes now have three different behaviors: percentage discounts, fixed amounts, or free shipping flags. Then we have customer level information. These are the customer level discounts we have. These customer status checks can stack, but can they stack? The code says yes, but is that intentional? There's no explicit design decision here. It's just an accident of implementation order. The tax calculation has also grown more in complexity. Tax now branches by region with special VAT handling for Europe. Finally, shipping gets calculated with its own set of premier customer rules. Notice how the premium customer logic reappears here in shipping, completely separate from where we handled premium discounts earlier. The premium concern is now scattered across two different sections of this method. The fundamental problem: there are multiple independent concerns. Bundles, promotions, customer tiers, regional tax, and shipping rules are all tangled together. Every new requirement forces you to understand how to interact with all existing requirements. The method has become unmaintainable. Now, what are the independent dimensions along which pricing varies? That's a fundamental question which we have to ask here. You have four independent axes. You have the base pricing logic, which is simple multiplication or bundle detection or tiered pricing. Then you have discount applications, customer level discount, promotional codes, volume discounts, stuff like that. You have tax calculations, which are regional rules, VAT versus sale tax, and exemptions. And finally, you have shipping rules, which are standard rates, premium free shipping, or weight based. These are axes of variation, dimensions along which the system changes independently. Bundle logic does not depend on customer discounts. Tax rules don't apply on promotional codes. When axes are tangled, adding an option to one axis requires modifying code for all the others. When they are separated, adding option requires one new implementation. Now, what's the solution to this? The solution is to decompose this monolithic structure into small composable pieces. Each piece handles one concern. Complex behavior emerges from combining these pieces. Now, first, let's define an interface that establish a protocol for pricing rules. This interface says every pricing rule takes the current pricing context and returns an adjustment to apply. Now, let's see what the context contains. This context contains everything a rule might need: the order, the customer, current totals, and so on. And here's what the adjustment looks like. The adjustment describes what to change: adding a fee, applying a discount, or calculating tax. This abstraction is powerful because it treats all pricing concerns uniformly. Whether we are calculating tax, applying discounts, or handling fees, they all follow the same protocol. Now let's build the pricing engine that orchestrates these rules. Sorry. The engine itself maintains a list of rules and provides a method to add them. This is how we'll configure different pricing strategies. Now, here's how the engine calculates a price. We create a context, then iterate through rules, asking each to apply its logic, and finally return the final price. Notice what the engine doesn't know. It doesn't know about premium customers, promotional codes, tax regions, or shipping rules. It only knows the protocol for applying rules. This separation of mechanism, how the rules are applied, from policy, what rules exist, is the key to flexibility. Now, each concern becomes isolated in its own rule. Here's the premium customer discount. This rule checks premium status and returns the appropriate adjustment. It doesn't know about bundles, promotions, or tax. It has one job: apply premium discounts. This is how regional tax works. All tax logic now is in one place: US sale tax, EU VAT, all the regional complexity encapsulated. Bundle, discounts, promotional code, shipping, each becomes its own focus rule before following the same pattern. Now, configuration becomes straightforward. Here's how we set up pricing for standard customers. We're composing different rules for different customer types. Same engine, different configurations. For premium customers, we use a different set of rules. Now, the fundamental insight: monolithic code forces you to predict all future requirements upfront because every change touches everything else. Composition lets you discover requirements over time because each concern is isolated. When bundle discounts are Required, create a new rule that only understands bundle logic, nothing else.